So today's lesson, for the first time, what we're going to be doing is looking for a designated angle. And we've not done that. And the situation is this. We're solving right triangles using sine, cosine, and tangent. And today we're finding the measure of one of the acute angles from this right triangle. So, this is what we're going to do. Number one, we look at our example to find out how to do this. We're finding the measure of angle A. All of a sudden, we're given two sides, but no angle. When before we were given an angle and one of the sides, but today we're looking for an angle. And the first thing I always say is find and label your reference angle. The reference angle in this case, since they do not give you one of the acute angles, the reference angle will be the angle you're looking for. So the angle you're looking for is going to be the reference angle. Where's the reference angle? If they're saying find the measure of angle A, the reference angle will be angle A. We'll call that our theta. And we must use a reference angle theta because, again, we're going to be using the relative terms, like opposite angle, adjacent angle. And they mean nothing unless you have a starting point, a relative point. In relation to angle A, what do you think this side's called right here, BC? Using a relative term, what is the name of that side? Say it again. Opposite. Because if you forgot, if you could imagine a line coming out of the center of theta, it always points to its opposite side. It's the side that's way on the opposite side of the triangle. So we'll label that as the opposite side. My focus is on the two sides that are given. So I look at this side, AC, and I see that's given. So with respect to this angle, what would the name of this side be in terms of a relative term? Adjacent is correct, because we define the adjacent as the leg that actually touches the reference angle A. And of course, this is the hypotenuse because it is the longest side of the right triangle. But we're not even concerned with the hypotenuse because look at that. They're not giving you H, and they're not asking you for the H. So let's just use this knowledge, because in the next step, guess what? Now that, here, let me back out. Look at this. It says find and label your reference angle. We use theta to mark the angle I'm looking for. Then it says mark the sides with their relative terms, like opposite, adjacent, hypotenuse, which we did. It's a C diagram. But for number 3, it says the side which trig identity we need based on the sides that are involved. Well, if you look at the triangle, the sides that are involved are the opposite and the adjacent. Because they give us the opposite and they give us the adjacent. So what we do is we recall that the definitions of these trig identities, we define them in terms of ratios. So which ratio involves the opposite and the adjacent? Well, the sine is opposite over hypotenuse. Not a good choice. The cosine is the adjacent over the hypotenuse. Still not a good choice because these two involve the hypotenuse. Now the tangent is the opposite over the, I think there's a mistake there, cross that out. Just put tangent of theta equals the opposite over the what class? Thank you. Bless you. So the tangent of theta is the opposite over the adjacent. A quick way to remember that is that thing that I taught you about the other day. So, ka, toa. We said the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So which one do we choose? That's the big question. Do we use sine, cosine, or tangent? Tangent for sure. That is what we choose. So right here, we choose the tangent, and what I do is I just write the whole thing out. The tangent of our reference angle theta equals the opposite over the adjacent. And at this point, we substitute. Next step, substitute. That means fill in everything you can. So we write tangent of theta. Do they give us a value? I'm going back to the triangle. Do they give us a value for theta? No. So we can't help that. So we just write the tangent of angle A, and that equals the opposite side. What is the value for the opposite side? And then the adjacent is 30. So when we fill this in and substitute, it's going to be the ratio of the opposite side, which is 24, to the adjacent side, which is 30. So if you didn't copy that down, take a second and copy that down, because there's something I got to show you, and we're done. The lesson is done. So make sure you got that copied. And I'm going to start in 2 seconds. You grab your calculator, because this is calculator work. And let me explain something to you. At first, it's going to seem kind of weird. And I cannot give you the full explanation behind this because you know this is not a trigonometry class, this is geometry. But I'm going to show you a little maneuver, and you just got to get used to it, practice it a few times, and you'll be just fine. I mean, I could give you a reason later on, but I don't want to convolute this lesson. So when you're solving for A, but the left-hand side says the tangent of A, or it could say the sine of A, or the cosine of A. But when you're taking the tangent of A, you can't, solving means isolate that A. So the only way you have of isolating it is to do the following. The only way to remove the tangent, you see that tangent right there, is to literally remove it and move it to the other side of the equal sign. And when you do this transformation, you're going to get A all by itself. But when you put the tan on the other side, you have to add a little extra added feature. You got to put an exponent of -1 right there. And then you can apply the 24 over 30. So the first thing I had to do to solve for A was get the tangent to the other side. And in moving it, what did I put? A -1. And the way this is read is you read it as A equals the inverse tangent. Whenever you see the -1 there, it's inverse tangent of 24 over 30. So copy that down. You don't necessarily have to circle this and put the arrow each time. I'm doing that for instructional purposes, but that's going to be A equals the inverse tangent of 24 over 30. Now I get to show you how to use the calculator, because one more step and we're done. Excuse me. So you grab a calculator. Please make sure your calculator is in degrees. So turn that on. You see how it's got degrees right there. So what you're going to do to find the value of A, the measure of angle A, this is what you got to do. Before I start, I want to say, notice that's the inverse tangent. If you take a close look at the calculator and you look at sine, cosine, and tangent, if you look above the sine, cosine, and tangent, you're going to see tangent to the -1 power, cosine to the -1 power, and sine to the -1 power. Every button on this calculator has a secondary function. Every button on this calculator has a secondary operation that it can perform. The secondary function to the tangent is its inverse, the inverse of tangent. The secondary function of cosine is inverse cosine. And since our problem states we need to find the inverse tangent of 24 over 30, that's exactly what we're going to do on the calculator. So let me back out again. And the way this is performed is by taking 24 divided by 30 and press equals 0.8. Now, once you have the 0.8 in there, we don't want to take the tangent of that. We want to take the inverse tangent. So to get to the inverse tangent, we have to hit the second button, because that says I want to use the secondary function of the tangent. So I hit second, and see how the second comes out right there. And now when I press tangent, I'm not taking the tangent, I'm doing the inverse tangent, and that gives me the measure of angle A now is going to be 39 degrees. I just rounded to the nearest whole number, the nearest degree. And if you notice, you have 38.6. So what does that 6 do to the 8? Stay the same or go up? Thank you. And so the problems we're doing today, we're just rounding to the nearest degree, which is the nearest whole number. And that is our final answer. So before I turn off this video, this recording, I'm going to ask you first, do you have any questions? Then if you don't have a question, I'm going to ask you to please flip this over. Let's do number 1 kind of like together as a team. And we'll do it kind of fast. Don't forget, this might help for you to remember SOHCAHTOA. Again, it tells you that the sine is opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So we go over there and remembering the steps. Remember, they want you to find the measure of the indicated angle using sine, cosine, or tangent. Leave your answer to the nearest degree, whole number. So the first thing is we identify our theta, and that's pretty easy because it's right there. The second thing after a while you won't have to do this, but with respect to this is theta, identify the two sides that are given. Like for example, this long side, that's always the what? And the student said hypotenuse. Thank you very much. And with respect to this as being theta, this side that's given, way across on the other side of the triangle is what? Opposite. Well done. From this, we're dealing with an hypotenuse and an opposite. So out of the 3 choices, do we use sine, cosine, or tangent? And what is the class telling me? Sine, thank you. Because the sine is the opposite over hypotenuse. As a matter of fact, they don't give us the adjacent. That is the adjacent side. It's the leg that touches theta. But they're not giving that to us, and they're not asking us to find it. So don't choose any of the trig identities that have an adjacent in it, like cosine has the adjacent and tangent has the adjacent. Sine. So me being an old-fashioned teacher, I say show every step you possibly can. Write down the identity. Identity is the equation. So we say the sine of our reference angle theta equals the opposite over the what? Thank you for that, hypotenuse. And at this point, just fill in the values. We don't have a value for theta, so we'll just leave it as the sine of theta. Do we have a value for the opposite? 51. So we're just going to go 51. And we have the value for the hypotenuse, which is 55. And since we're looking for the angle theta, this is one of those situations where we got to remove the sine away from the angle. How do we do that? Bring it to the other side of the equal sign. Thank you. It's like a bunch of college students. I'm very proud. So that leaves you with theta all by itself, but now we put the sine over there, so we have to write sine again. But what's that little added symbol we have to put there? Yeah, exponent of -1. And then we put the fraction 51 over 55. And that tells you we're doing the inverse sign of 51 over 55. It's the inverse sign, not the sign. So that tells you how to do the calculator work. So we press clear, make sure it's in degrees. And we are going to, what do you think we do first? Thank you. They said 51 divided by 55 equals. Now we don't want to take the sine but we want to take the inverse sine. So how do we access? You have to hit second first, because that's a secondary function of the sine button. So we hit second. And which one do we hit, sine, cosine, or tangent? Sine. And that gives us our degree measure of theta, which is going to be, to the nearest whole number would be 68, because the 0 lets the 8 stay the same. So the measure of angle theta equals 68. And because it's an angle, we have to put some little symbol there for angles, so we put degrees. That means the measure of angle theta is 68 degrees. And that's the T. That's it. You can copy that down. I think that it would be very wise for us to practice this. So I'm going to stop the recording and we'll get to work. I'll help you if you need help.